This conference will now be recorded.
Hello, hi, good morning all. Are you able to see my screen now?
Good morning, RK. Yeah, able to see.
Yeah, hi. So this is a typical JVM and middleware software interaction diagrammatic representation. So what basically this diagram is showing you is the high level interaction between the JVM and the middleware. Middleware is nothing but the type of application server that you're using where you're deploying your all war files and EAR files of the code and business logic that you deploy into the type of application server that you're using. It can be WebLogic, or it can be WebSphere, or it can be JPOS, or it can be Glassfish, Apache. It can be anything. Okay. So as you can see, the threads allocation for a Java Enterprise Edition application are done mainly between the middleware kernel. Most of the threads are created inside, okay, inside the JVM and inside the middleware kernel is nothing but the application. Okay, there are some there are some situations and exceptions where application itself or some APIs creates threads, okay, directly, but this is not a best practice. For every application server, you will have a main thread. Okay, when we talk about thread dump analysis, we'll have main thread. You will have a lot of processes, and each process will have at least one thread. And one main thread, what it will do is it will create a lot many other threads. Okay, but everything that happens only through the main thread. Okay, and most of the threads, what you need to keep in mind is most of the threads that reside inside the JVM, what they do is they are completely managed internally within the JVM. For example, if you take garbage collection, right? In order to free up the memory or in order to handle some concurrency, I mean, the JVM has to handle some kind of internal threads such as garbage collection threads. What they'll do is they basically handle the concurrent garbage collections. Even the garbage collection happens concurrently when you have excessive concurrent hitting on the application. One moment. Okay, and also you need to, before you give, if you want to know how many threads a JVM will handle, you need to have the detailed understanding on the application, and it purely depends upon what type of RAM and the type of CPUs. It completely depends upon the type of hardware configurations that you're using. Accommodating the number of threads will always depends on the version of JVM that you're using, the type of JVM that you're using, and the configuration, the hardware and software configuration it has. So, s- so since most of the threads are actually, the allocations happen in Java EE container. If you look at after the middleware, if you see the Java EE business services web container, EJB container, right? So basically all the thread allocations happen in the Java Enterprise Edition container. So for that you need to understand and recognize how much thread stack is required. Okay, so how much thread space you need to give, stack size. Stack size is the important part because every thread that is created, right, all the details of that particular thread will be holded by something called stack area. So when we talk about that stack area, it is one of the main important memory area inside the heap. Out of 5 memory areas that we have inside the JVM, stack area is another important area where it will contain all the information of the thread, where it will hold all the information of the thread. So I'm sorry, my throat is bad today, so please excuse me. Uh, so that's what you have to for every thread allocation that happens inside the JV and Java Enterprise Edition container. You need to understand and recognize how much stack trace is required when you want to accommodate more number of threads before you take thread dump data. When you want to take multiple snapshots to understand the complete picture of all the threads, what they're doing at what point of time, you need to, the first point is always to check the thread stack trace, how much allocation that has been given and how much you need to give. So this basically what this will do is this will allow you to understand quickly the type of request, okay, that Java EE container is attempting to execute. So if you before you take multiple thread dumps, I told you yesterday, if you remember, there is something called a priority of threads. You need to, in that direction, you need to understand. Like, for example, in the thread dump analysis in parallel, the first thing that you see is blocked threads. Then you see for the waiting threads. Then after identifying all the blocked threads and waiting threads, so the next immediate action item is what to do next is the question, right? So for that, there are few cases that you need to take care before you start investigating the thread dump analysis. But again, from a thread dump analysis perspective, uh, the main thing that you learn is how to differentiate between the different thread pools. Even yesterday I told you the same thing, right? In every time, if you're running out of threads, you immediately go back and increase the size of the thread pools, right? So again, increasing the thread pool, okay? Increasing the thread pool will increase the concurrency on the application, but not the response time. Okay, it will not optimize the response time. It can accommodate more number of threads. It can allow the user to have application to have high concurrency, but it will not improve the performance. Okay, the only efficient thing with respect to performance optimization is the development team has to write an efficient code where there are no deadlocks happening, okay, where there are no threads are waiting for a very long time based upon too many conditions. So hello, hello,
Yeah, okay.
am I audible?
Yeah.
Yeah, it said that the headset is disconnected, so okay, I reconnected it again. So again, you have to differentiate between the different thread pools that you have, that you found in JVM, and to identify and troubleshoot, right? You need to identify the request type. And Mahesh actually asked me a question yesterday, right? So what are the maximum number of users per thread? So basically, when we talk about a thread, right? Thread is a specific task. Thread is designed to execute a specific task. So if we talk logically, so what happens is, if you have some high user base, there is some percentage of concurrency, right? For example, 2 to 5% of the total number of users will be accessing the application concurrently and simultaneously. It means that they keep hitting the same functionality at the same point of time without any time gap. So what happens in that place is there is no straight answer like this many numbers, this many number of users will be aligned or assigned or will be handled by a thread. So when we talk about concurrency, when we talk about multi-threading application, right? Multi-threaded concept in Java. So what happens is every user will access that particular thread. Okay, because even yesterday I told you this point, right? If a thread, what the thread will do is thread is a very lightweight process which will share the same data, same code, and same address space. Okay, until and unless if it is not having any of the restrictions. If you, for example, if you take any of the banking application, right? For example, if you take a joint account, I mean, if myself and my father are having two ATM cards, and we are doing the same activity at the same point of time, trying to withdraw the money, and if we both of us are doing at the same point of time, so you will see some kind of unexpected behavior. Like if I am withdrawing, if there is a cash of 10,000 10k balance, so if I am trying to withdraw some 6k, even if my father is I mean trying to check his balance, so it will still show 10k after withdrawing 6k in parallel. Okay, if I'm taking the money in another ATM parallelly, if I'm taking 6k, it should show the balance as 4k. My father is he's still seeing 10k. That means that there is no if you might have heard about something called synchronization block, right? Using synchronization is nothing but they will write a block on a particular thread. So what it will happen is, so one user at a time, he can use that particular thread only once. If a second user has to come and use that thread, the first user has to complete his task, and the remaining users who wants to execute that or who wants to make use of thread, they have to wait in queue. Okay, basically using this synchronization concept as part of coding practice is not a best practice in any of the Java coding. The reason is because if they are using too many synchronized blocks on each and every thread, what will happen is you will see very high response times. Okay, so the thread, the number of users using a single thread depends upon the type of application, the type of JVM, the type of requirement that we have, or the type of activity the thread is doing, and the type of privilege that each user has to access that thread. If you use IRCTC or if you use Amazon, multiple users will be searching for the same product, right? But it can use the different data. They will search for the same product. If you have some 50% on all the BS4 vehicles, so people will start searching for all the BS4 vehicles, right? Like mostly if you have some 2.5 lakhs discount on Duster car, so all the users will try to search for this particular item for this particular car, and they will try to check the details online. That means that many of the users are trying to use the same search thread, right? It can, so there is no problem in access in giving the privilege to all the users so that they can access that thread concurrently, parallelly, or simultaneously. But when you come to any of the sensitive applications or projects or any of the banking applications, right, they use a concept called synchronized blocks on that particular thread, so that what it will happen is it will set a privilege like one user can access this thread at one point of time. So once the user completes that specific task, so he can go ahead and he can the second user comes in, then he can do it. But whereas there is a different question that can be asked: how many number of threads a JVM will accommodate? This is another question. Okay, So accommodating the number of threads to a JVM, I told you, right? It depends upon the type of it. Can be for 32-bit and 64-bit, the numbers are different. For 128 KB stack space in 32, you will see you can accommodate some 15,000 to 18,000 threads. And if it is 64 KB, sorry, it is a 64-bit machine. If you are giving it, I mean, stack size of uh, 256 to 512. So again, it depends. It can accommodate up to 25,000 threads, and again, it depends on uh, the thread pool, how a thread pool will work in Java, and how the thread pool executor will make all the thread pools to work. Okay, let's talk about what is thread pool and what is thread pool executor. Basically, what a thread pool will do is, a thread pool, you will have multiple thread pools in JVM. Uh, I'll show you where you will have all these thread pools in WebLogic when we deploy an application. Basically, a thread pool is a collection of all the pre-initialized threads. That means that threads are created, they're ready to run state, or they might be actually running. So generally, the size of this collection, the thread pool, is fixed, but this is not mandatory. You can increase the size of thread pool in the way you want, but again, you need to give these values depending upon what numbers you see with respect to performance. If you are seeing any high response times, or if you are seeing more number of struck threads or more number of deadlocks, right? And every time, if you have a test which has to run for 4 hours and you are running it only for 1.5 hour or 2 hours, and you see out of threads, okay, in such cases, the only option you will have is you need to increase the size of thread pool, okay. And at times you also need to check the size of the collection. So how many threads it is actually collecting, so how many threads it is accommodating. So this particular metric, you need to go back and you need to go to the application server, and you have some metrics there. You can directly increase the connection pool, thread pool, and you can make necessary changes. Okay, so basically what happens in thread pool is it works on it works on wait in a queue like structure. You must be knowing first in first out, right? So what happens is when a thread completes its execution, the thread pool immediately it will pick up a new task from the queue and it will execute it. So when all the tasks are completed, the threads remain active and wait for more tasks to come in the thread pool. It doesn't mean that once the thread completes its task, okay, so it will not go to idle, or it will not go to terminate state. Once it completes the activity, or some completes the entire execution, basically what it has to do is it has to pick up a new task, okay, from the queue. So every time a thread is completing the execution, it will remain active and it will wait for the remaining tasks in the thread pool to come. Okay, so there is another component called watcher. Okay, what this watcher will do is this watcher will keep watching this queue. This queue is called blocking queue again. So what you will know from the blocking queue is uh, the watcher will wait and see for some new tasks. You can see if at all they have some new tasks that are coming, right? You can see all the new tasks that are coming in the blocking queue. So what this watcher will do is the watcher will continuously watch this queue to see if there are any new tasks that are coming and waiting in the blocking queue. As soon as the tasks comes, as soon as the task comes, right, then I mean the new tasks, threads, what they do is they again start picking up the tasks and it will start executing them. So when it, the question is how many thread pools we have uh, in Java. So again the answer is it depends. You can have multiple thread pools depending upon the size of architecture that you have, or depending upon the type of application and what each thread is doing. So considering all these parameters, you set some n number of thread pools, and you see the size of the collection of this thread pool. And again, what you have to remember is the size of the size of the thread pool collection is not fixed, and it is not mandatory that you have to give only 512 or 256, or it has to give, it has to collect only 10 threads or 20 threads. It is not like that. Depending upon how your application is behaving, you tune some parameters to see what is happening. Accordingly, you set all these values. Okay. uh, don't worry about all that stuff. We'll try to run a sample test to see how threads are behaving. Okay. And there is to take care of all these thread pools, you have a thread pool executor in this one. Okay. So what if you take from, if you consider the Java from Java 5 version, Java concurrency API, which is an inbuilt API, this provides a mechanism called executor framework. So the executor framework is nothing but the thread pool executor. So what this thread pool executor will do is it will separate the task creation and the execution of the tasks. Okay. So, and what you have to remember about thread pool executor is the thread pool executor will only implement the runnable objects and send them to the executor. The remaining states of the objects it will not touch. Whatever the objects that are running, okay, they will send it will send all of them to the executor. Now the role and responsibility of a thread pool executor is it will take care of the thread execution, instantiation, and it will run that thread with all the necessary what action items or necessary tasks. So thread pool executor will be responsible to take care of all the execution, instantiation, and all which task has to uh, which task has to be executed by what thread. So this all parameters will be decided by thread pool executor. Okay. So, and if you go back and see just a minute. Oh, sorry, just a minute. So, and we already spoke about different things that we have in thread dump, right? For example, if you take a thread, once you take the thread dump, right? We have multiple ways to take a thread dump. So once you take a thread dump, the first thing that you see is the thread name. Okay, the thread name you can see from the name will be given by the middleware vendor. Okay, like, so whatever the thread id or whatever the thread name, so that you see, it is, you can see the thread name and thread id along with its associated thread pool name, and you can also see the thread state. You can see all of them from the middleware kernel. Okay. And the second thing is you see the thread type and thread priority. When I say thread type, right, it will tell you what thread it is. Is it a daemon thread or it is a user thread, non-daemon thread? So basically, what you get all this information only from the middleware software. Is nothing but WebLogic or WebSphere. So what they do is they typically create their threads as daemon threads or non-daemon threads, which runs in the background. Mostly the middleware kernel, the WebLogic, what they do is they they create all the threads as daemon threads, which run in the background, because whatever the Java that you install, it comes with JDK and JRE, and the JVM will be deployed on the middleware application. on the middleware part, right? Which is again the WebLogic or WebSphere. So there are some inbuilt features of JVM, which is also called garbage collection. So most of the times when this middleware software, right, they every time when they create, they try to create all the threads or all the threads as daemon threads. It means that they provide all the services to the user. For example, uh, garbage collection again. So after that, you will see the thread ID with something like this. Let me show. I don't know if I right. I forgot. Okay. I'm sorry. I'll share you some sample thread dump. Okay. You can, what you can do is, there is something fastthread.io. You must be knowing that, right? I'll share you one sample thread dump. What you can do is just add the file, browse, and you need to click on analyze. I can directly show it to you, but I don't want to do that. I'll share you the sample thread dump file. Just add here. You browse the file. I'll send it on the email, but not today or tomorrow. By end of tomorrow, I'll share the thread dump sample thread dump file. You can just add this file, click analyze, and tell me what you have identified. Okay. Anyhow, I'll show it to you and I'll explain it to you very clearly. But before that, I would like everyone to just add that file in in the online analyzing tool. Just click on analyze and tell me what happened. That's all I need. So when I talk about the thread ID, if you look at this part, right? So when you see
Okay,
the
you said
thread
that.
dump,
Okay, able to hear
sorry.
me?
Yes, tell me. Tell me why.
You said you'll share heap dump also. Can you please share with that?
Heap dump, I don't think so because heap dump is the size is very bigger. So I'll try to send it, and I'm not sure. That is a banking heap dump. So I'm just I have so many thread dumps. I'm not sure about the heap dump. Heap dump, let me try. I'll try to send it. Okay. Heap dump, you know, right? You where to know and where to analyze this heap dump. You know it.
No, online I don't know.
Heap hero. Heap hero.io. Okay. Once you have this file, you need to uh, click same thing. Heap dump. You need to browse. You need to add. You need to click on analyze. Let me try sending you one sample heap and sample thread dump. Let us see what you'll analyze. Okay. But tell me what you understood from analyzing. That is how you will add some experience. Okay. So Java thread ID is nothing but a TID, right? This TID is basically is unique for every thread. So this is the actually this is the Java thread ID obtained via java.lang.thread.some package, and this is this is an inbuilt thing. I mean, the thread ID generation, right? It happens again from the middleware software. So it has some package. It is obtained from Java lang dot package something, and there is a native thread ID. If you remember, yesterday it spoke about native thread. Can anyone of you tell me what is native thread? Any thread which is mapped to operating system thread is called native thread, right? So if you want to check the native thread ID, you will see something like NID equal to 0x something like 14E0 something. Okay, so the this is one of the important value which is called native thread ID, which you see NID equal to something, some value, right? 0x14E0. This is the crucial information. What this native thread ID will do for you is it will allow you to correlate which threads from the operating system perspective are using the high amount of CPU inside your JVM. With the help of NIDs, right? If you take all these NIDs, if you filter with by a drop down called NID native thread ID. So what this native thread ID, in what way it will help you is, it can help you to correlate and to identify which threads from the operating system perspective are using the most amount of CPU inside the JVM. Okay, so Java thread and detail. Basically, Java thread state, you will see it, right? Is it running or is it blocked, or is it waiting for a lock? Is it is waiting on condition? You will see the state, and the state is running or blocked. The details are nothing but it is saying that waiting for a. If you look at the details, I'm not sure if we have some details here. See, it is saying that the state is runnable. And if you see zigzag.threadum.demo CPU high usage is the details here. Okay, so okay, the details are like this: test deadlock.java. And if you guys are aware of, there is one site called Crunchify. Okay, it's a very good site. What you can do here is there are so many programs here. Like you can you have some programs. If you have that program in your Eclipse IDE, right? What it will do is there is a program to generate a deadlock. There is one program where he has set some infinite looping, so continuously the objects gets created and it will automatically create a deadlock situation. When that is happening, you can integrate your IDE with JProfiler. Okay, you can integrate your Eclipse with Apache Tomcat or WebLogic. You can run it and you can take a thread dump. You can see the deadlock. So we'll do that. I'll show you like a real-time scenario. So I mean I'll show you what exactly we do in from a real-time perspective, like how we take a thread dump, how we have to analyze what are all the parameters we need to look at. So what are all the various tools? I'll show you all of them. But native thread ID, again, it will tell you why the CPU is increasing. And this is also one answer when you were asked saying that what is why what is the what are the main reasons, for what reasons you are seeing the high CPU utilization. So how do you diagnose a CPU spike? So what is your uh, take on how do you investigate or how do you troubleshoot high CPU utilization? One is you see the number of garbage collection cycles. If you see if you try to see the high excessive garbage collection, high GC pause time, you check for the heap, the thread dump analysis. In the thread dump analysis, you check for the native threads. The reason why you check for the native threads is because native all the thread IDs which are mapped to operating systems are called native threads. So When you are troubleshooting with the native thread IDs, you are trying to find out which native thread ID, which native thread among all the threads is taking high amount of CPU from my OS perspective, from the operating system side. This is how this is one solution to investigate the high CPU spike, high CPU utilization. So, and if you go to Java thread stack trace, right? This is another important, another most important data that you will find from the thread dump, Java thread stack trace. So basically what it will tell you is, it will show you where you have spent, this is the place where you will spend most of the time in analysis. Thread dump analysis will actually happen in Java thread stack trace. So 90% of your analysis will happen from here, and all the information that you need in order to pinpoint the root cause rate of many problem pattern types, you will get all this information only from the Java thread stack trace. It will give you the complete information of each thread. Okay, so you will learn everything day by day, more from your thread dump analysis experience. If you start taking thread dumps, right? If you are continuously taking thread dumps for every project from today for the next 3 months, you will become like an expert. You will understand all these different areas, but it will add more expertise experience when you start working, when you start analyzing more number of thread dumps. It's not just taking it. Once you take the thread dump, you need to go, I need to analyze the thread dump. You need to look at all the thread dump part. So what it is doing, and how each thread is working. So this is this particular diagram, right? This is Java hotspot VM. You have different virtual machines, right? Different JVMs from IBM, JRocket. Hotspot is basically from Oracle, Sun people. So in order to give you some better understanding, I have captured this diagram. So this diagram, I mean, it will show you some visual breakdown of all the different components that we have inside a hotspot VM thread dump, and what are all the different thread pools you will find. If you look at the components, right? The first one is full thread dump identifier on hotspot version. So in the full thread dump identifier, it will give you the hotspot name, 64-bit, and the hotspot version from Oracle Corporation, something like that you will see. And this is basically a unique keyword that you will find in your middleware. Okay, it will give you the complete full thread dump identifier name and hotspot version. And if you can see the diagram, you have several pieces of information, and these pieces of I mean, the different components that you see in the thread dump view inside Java hotspot VM. So it depends on the type of issue that you see. Okay, so it will be, I mean, you have to investigate all these areas depending upon your problem pattern. Okay, so what, depending upon the type of problem that you see from every thread dump section, so you have to go to, you will understand to which area you have to go and investigate. Okay, so most of you must be aware, if you want to take a thread dump, most of the people still say, no, I mean, I see people saying this answer. So how do you take a thread dump? They go to blocks, okay, and they see a command, kill -3 and PID. It means that kill -3 24727 is the process ID. What it will do now? Why is this
It will
command
stop
used for?
it will stop the process.
No. Basically, this command is used to take a thread dump snapshot on Unix servers. Okay, and this particular thing has been this particular thing is available only from Java 5, I guess. Before Java 5, there is no kill -3 command uh, which is used for taking a thread dump snapshot. So even I am not sure which version this is not available and from which version is available. You can Google on that. But kill-3 process ID will help you to take a thread snapshot only on the Unix, not on like Windows and everything. It is only used on Unix servers to take a thread dump. Okay, if we talk about the first section here, Java Enterprise Edition, middleware thread pools, application timer, and other internal threads. So this portion is the core area of the thread dump where you will typically spend most of your time. Okay, the most of your time again you spend here, the analysis time. The number of threads that you see again depends upon the type of application server that you use, the type of version that you use, and other third party libraries. Because some of the application servers, the middleware softwares that you're using, right, it can have their own libraries. Okay, when I say their own libraries, some of the application servers will have their own threads. Okay, but again there are few application servers. Once you deploy your application will start creating custom threads, which is not generally a best practice, because all the threads has to be created from the middleware software. They have to be managed from, they have to be completely managed by the middleware portion, the middleware software that you're using, WebLogic or WebSphere. So that is how the performance the performance numbers that you see go as expected. But when you go with some kind of application created custom threads, right, I mean we are still not sure how they'll behave when the application itself is creating some kind of threads. um, Basically even that is not a best practice. So we always use the application servers which are completely taking care of the creation of threads, managing the threads, which will automatically happen from the application, I mean from the middleware software side. Okay, so if you take the second part, right, there is something called hotspot VM thread. Okay, so these two things, this is the place where you spend most of the time. If you go to the hotspot VM thread, right, this hotspot VM thread is nothing but these are completely uh, what to say, these are completely internal hotspot operations. That means that when I say hotspot VM thread, this is an internal thread managed by the hotspot VM in order to perform some internal activities. Okay, internal native operations. So typically you will not worry about all the hotspot VM threads unless you see something like a high CPU utilization. Okay, until and unless you see some high CPU utilization, you don't go back and see for a hotspot VM thread. You only consider the thread pools here, the WebLogic main thread, and other threads that are created and managed automatically inside the JVM with the help of Java Hotspot VM. The first two sections you worry. Forget about Hotspot VM thread. Okay, you have to worry only when you see some kind of high CPU utilization. So the fourth section, if you see hotspot GC threads, right? So basically these GC threads, what they can do is, right, JVM will initiate some periodic GC activities in a parallel manner. So every time the objects are coming created, uh, the cleaning happens in parallel, right? So what happens here is when the GC is happening in parallel, is if in a continuous manner, so you will see a overall reduction of the GC time. So when the GC time is higher or lower at times, again you see something like a CPU utilization. I mean, so to check all the threads, if you see any high utilization, high CPU utilization, or if you see high amount of GC time, or if you're seeing more number of periodic GC cleanups, if you see very often the GC is coming, kicks in, it is doing some garbage collection. So what you do is you collect all these GC threads, okay? So to identify the root cause with GC related problems such as excessive GC, memory leaks. So to see the high CPU from both the operating system and Java processes. So by analyzing all the hotspot GC threads, you will be able to correlate all the different issues that I spoke just now, like the CPU utilization, memory leaks, excessive GC. Okay. Again, uh, you will learn a lot about this GC threads again, because again when I talk about GC, you also need to analyze. If you want to thoroughly investigate the GC activity, you also need to analyze the GC logs. To analyze that GC logs, to see what happened with GC, what you have to do now? Where do you analyze GC logs? Okay, so this is nothing but like heap hero and fastthread.io. This is gceasy.io. I don't have any GC log file. So what you can do is you can bring the GC file here, log file here. You can upload here and you click on analyze. So the unique feature of all these analyzers, right? They have some intelligence of the product what we have in live GCZ or fast thread. They have its own intelligence in identifying the problem suspects, and it will give you a very high level report in detail, which will where every performance engineer who is a beginner level, who is in the beginner level, can also understand something from the report that is given by this online analyzers. It will give you the pie chart representation of data. It will tell you how many suspects you have, how many problems you have. So it will tell you all of these things. Okay. So the last okay, the last one is JNA global references count and Java heap current utilization view. So the JNI is nothing but the number of object references, okay, which are internally managed by Java garbage collector. So it will directly identify. The references, the objects with no live references in the Java code. Okay, so you can directly see the number saying that JNI global references equal to 2185. It means that these are all the objects with no live references in the Java code. It means that you can take them off. Okay, so you can, when I talk about heap current utilization view, it will directly show you from JDK 1.6. It will give you the complete numbers of heap. Okay, like right, complete utilization of heap is nothing but the Eden, the S0, S1, younger generation, older generation. You will see all the metrics just by seeing it, the heap current utilization window. So you will get all this information from a red dump analysis. And see, this can be a bit confusing, or you may not understand in one single theoretical class. But thread dump analysis is an continuous learning process, right? So basically, what every performance engineer will do is he will take a thread dump. Have you ever taken a thread dump? I'll tell you the limitation of the evaluation that can happen to any of you when you go for an interview. Have you ever taken an thread dump? Yes. How you have taken? What are all the different ways? So what is the extension of thread dump? Because I have seen many people who are working in the service-based companies, especially the panels, whoso is interviewing with 12 years or 15 years of experience, they still keep asking you the extension of heap dump file, thread dump file. So what is monitor, what is lock, what is an index? So how do you optimize index? These are all, they start from very basics. So whatever we spoke till now is some kind of advanced thread dump analysis part. So don't worry about that. So you will get to understand all the concepts very slowly, and once you take this one right, I mean, once you start taking thread dumps, once you start using all these tools, once you know how to write this thread dump, how to read, so you see some different values in the thread dump, like thread IDs and native IDs. So you will see the state of the threads, you will see the description of the threads, saying that waiting on condition, waiting. So slowly you will understand what you need to do with the blocked threads and thread, and waiting threads. So but after all this analyzing, right, after all this analysis, if you want to investigate, so when the question is how you can investigate is the question. When you have such a question, when you have such questions, right? So first thing, you need to have good understanding on the thread states. Okay, when you have good understanding on the thread states, it will be very easy for you to understand thread dump. Okay, and this thread dump can be taken on any environment. It can be on the staging, it can be on the production, or it can be the QA, dedicated performance environment, which can be a mirror image or the exact replica or 1/3 size of your prod. Okay, so a typical web application, any application, if you take some average number, it will have 25 to 50 working threads. Okay, and adding to these threads, you will have catches added to it, and there will be some system threads, and all these threads will have one main thread which will completely take care of all the other threads. Okay, so what you need to keep in mind is how you have to, after analyzing the thread dump, what is that I have to do. Again, it is not you, it is the developer. But if you learn Java, you will learn how to optimize, and you will directly understand from where exactly is the issue. You need not even wait for the developer to come back. You can directly say that this is creating the problem. Okay, for that, what you need to do is you need to understand the application. First point, every time you take a thread dump, you need to understand the fundamental concepts of your application. So the technology components that you have and the way they have been implemented. And if you know all these uh, concepts, right, the infrastructure, the use cases, traversal, and if you are a consultant or if you are a senior performance engineer, you all the time you will not work closely with the development team, right? For that reason, and there are few situations for few projects. I mean, there are few projects that I was a part of. The performance team is with TCS. Okay, the development team is with Accenture, the DB team is with HTC. Okay, and the application team is with Cognizant. So when you are working with a multi-vendor client, where your work action items are distributed across different vendors uh, into bits and pieces, it is very hard for you to get in touch with, I mean, to work closely with any of the team, and you cannot get a complete fix within the expected time. I mean, the fix which is supposed to come in 2 days, it can go up to 20 days, or sometimes it can go up to 31 days. Some people, the other teams, work in different countries with different time zones, so you will not get the response. And there are some people will, they can feel like, why should I help to the TCS guy? Some Accenture guy can think like, why do I need to respond on this one? So for every time a business analyst or a business team or an application expert or an architect cannot come back to you and cannot explain you this is the issue, this is the fix that I have done. So when you are working as a consultant or when you're working as a senior performance engineer, you need to understand the application. You need to have some good experience in writing some Java snippets, Java code snippets. When you have all this information, it will be very, very easy for you to understand the problem, from which thread pool, what is the issue with what thread. By looking at by taking a thread ID and by taking a native thread ID, you will be able to troubleshoot and identify the root cause with the help of any of the profiling tool. Okay. So the second point is something like eliminate. 1 minute. Yeah, I'm sorry, I got a call. So eliminate runnable threads is nothing but don't worry running state. So they're already being actively scheduled, and you need not extensively focus on them like to understand what they are doing. Don't worry about the running threads. Okay. So only thing you need to look at is the blocked and waiting threads. Okay. And the third point is you need to eliminate the idle threads. Idle threads is nothing but there are some threads in the application, they are always in idle state. Okay, they can be either waiting for an incoming connection or sleeping for a period of time, or they're just idle. Idle means they're doing nothing. They can sleep, they can park, or they are waiting for some incoming connection, or they are waiting for some task. So what you have to do is you don't worry about the idle threads. They'll not do anything for you. Even if they're waiting or sleeping for valid reasons, you need not worry. If you see a TCP connection is waiting for an incoming connection, you need not worry much about that particular thread. So the expected nature of an application, a thread, the idle thread can be safely ignored. Don't worry about that idle threads as well. So what you have to understand here is you don't worry about running threads or idle threads. Just wait for blocked and waiting threads. Now, when I say, can you allow me a minute? I'm getting a call continuously. Okay, so when I talk about, I'm sorry about that. So yeah, someone is calling me continuously. Okay, so when I say analyze blocked and waiting threads, this is the most important part of your analysis. Oh my God, this. Yes. Sir, good morning, sir. నేను లక్ష్మణ్ నుంచి కాల్ చేస్తున్నాను సార్. Okay. Okay, I'm sorry. Okay, so yeah, when we talk about the blocked and waiting threads, I don't say you will spend 80% or 75% of the time. All your 100% of the time you'll spend here in this part, important part of analysis. So the first question is why are these threads are in blocked or in waiting state? Okay, basically they have to be in runnable state. The only question is why are they getting blocked or why are they waiting? Okay, so the threads which are waiting, right, they are waiting for monitors which have been acquired by other threads, right? Right, we spoke about them yesterday. We have two threads. uh, One thread is acquiring a lock and doing some activity. The remaining thread has to wait until and unless the thread one is completing its task. It depends again how much time that thread will particularly wait. It can be in waiting state or it can be in timed waiting state. Few threads, what they do is they wait for only for some time, for 2 minutes of time, and if they are not able to get that lock, they are not able to make use of that particular resource which is acquired by thread one, then it will move for and it will search for another task and it will execute. So that is how it will happen. So basically the threads will wait for monitors which have been, I mean, for resources which have been already acquired by other threads. Okay, the other threads which acquired these logs, which acquired these monitors, could be either they can be in the running state, or again they can be in also the blocked state waiting for other monitors. You understood this point, right? So you have some threads which are waiting. These waiting threads are basically waiting for some monitors which are acquired by other threads, for example thread 2 and thread 3. And this thread 2 and thread 3 can be in running state. It is again, it is not like they will be only in running state, they can also be in the blocked state waiting for other monitors. So using these thread terms, it is easy to scan for us to understand which thread owns the required monitor, and you can understand the situation better. Okay, so if you look at the thread dump, if you look at any of the thread, for example TCP connection with the thread ID is blocked state, and you will see a description like waiting to lock a monitor. Okay, so and you can also see TCP connection has obtained the monitor. So if you look at all the different threads, that is how each why each thread is waiting. So if you understand this waiting thread will get a monitor from other thread, then it is fine. And if that particular thread is waiting for 1 hour or 2 or 30 minutes for a prolonged period of time without getting any resource from other threads, then it is a bottleneck. Okay, the same thing with blocked. Blocked threads, what they do is they lock the resources, and they will not give these resources to other threads which are trying to do some activity. So this is one situation where you need to report to the developer. And the last point is you need to analyze thread terms over a duration. That means that it is very important to understand the snapshot of the thread terms that you take of the current execution context. So it is important for you to understand how many times you have to take. Okay, how many thread terms I have to take, because one snapshot would not be enough to reach the conclusion, right? So why the threads are blocking or why the threads are waiting. So you have to take some multiple snapshots for a smaller duration. This is a best practice. For a smaller, taking a multiple thread snapshots for a smaller duration will help you to understand what each thread is repeatedly doing what. Okay, the best practice, I mean, again, you will not do this in real time. It always depends on what type of requirement you have, what type of situations you have, and what is your performance goal or accomplishment. It depends on that parameters. I'll not directly tell you that. Basically, what I do is I take one snapshot for every 5 seconds, and I take multiple snapshots for a couple of minutes. Okay, you can also increase the duration between the snapshots based on your application needs, application context. It purely depends on the type of application, the type of testing, the type of flavor of performance testing. For stress testing, you take in one way, and load testing is a different approach, and endurance is a different approach. So 5 seconds, you can take one thread dump. Continuously, if you take for 10 minutes, you can correlate and see what in common what one particular thread is doing. it is blocked in all the thread dumps, that is a culprit. That is a primary suspect, right? So thread dump is a fair conclusion for all the performance issues. Okay, so you need to slowly, in a continuous learning process, you will slowly get more understanding on the thread dump. And if you have if you have some time, buy a book called Head First Java. It's like a story book. It will say it will take some 2 and a half months of time to learn all the Java concepts. Once you get familiar with all these Java concepts, you will directly understand what is this deadlock, why it is, what is a lock, what is a monitor, what is this java.lang.thread.join. In the braces it says that unknown resource. What does it mean? You are seeing a message like locked. In the braces you see some ID and java.lang.thread. How many of you know what is java.lang.thread? No one, right? And
It's a
again it
class.
says the right, it is a class. So it's an inbuilt class. So when you read the thread dump, you need to understand the native method, the type of class, on which class it is waiting. So how can I go back in the profiling tool and see this particular class, what this class is doing, how much CPU it is taking, how much memory is taking. So everything is interlinked, okay? And again, there are few race conditions in thread dump analysis. It is always the classic deadlocks, okay? Classic deadlocks, you know, right? We already discussed. And you always have out of threads. Out of threads is nothing but response time of your transactions uh, will go down rapidly, okay? Every page in your application, every transaction in your application will take more time to render. This can happen because of out of threads. Okay, the application for the first 1 hour, if you see the application throughput in the load test, if you see the throughput as constant, and now you're seeing it is going down. It is because it is one of the reason for running out of threads. Okay, and the application server or the database server are running with some kind of limitations. For example, if you have 100 requests, every alternate request is failing. Okay, that means that one thread is able to do execute and another thread is not able to execute. One thread is able to run, one is waiting, one is blocking. These all abnormal behaviors happen because when your application goes out of threads. Okay, so in such situations, you have to go check back out of threads and you have to see how many threads are being utilized. Okay, for that you need a thread dump. From the JVM level, you need to, if you will directly have a huge impact on the application, don't worry about that. If you want to go back and see if the application is going out of threads or not, you have to, you will see a very huge impact on the application. It can directly go down. Okay, it will not perform satisfactorily when you attach some profiling tool. Even if you start monitoring, you will not be able to get uh, the appropriate response. Okay, and the last one is the resource contention. This is the most common thing that happen in every application, every web application. You know that what is resource contention? What is contention?
Scarcity.
Right. Basically, the any contention will happen when two threads are fighting for the same resources. Right. So if two or more threads are fighting for the same resource, I mean same resources, no one will get the response, right? So the majority of the threads in the application will be fighting for the same resource. So if more number of threads are fighting about the application, what can be the reason? What is the issue? You have so much of resource contention. What is the first bottleneck you can think of? A small guess would work. Anything, any answer is okay. Anyone? No idea? Inefficient coding?
Yes, like the code is not written in a thread safe condition.
Right? And anything else?
And also the dependency, like resource waiting on other thread.
A few dependencies. I'm sorry. So when two or more resources are fighting for the same resource,
Yes.
the direct indication is inefficient coding and poor application design. Poor application design, if you have poor application design from the applications team, too many threads will fight for the same resource. You need not even test that application. You can simply say that fix this, makes this functionally stable, come back to us, we'll do performance testing. Okay, you can say this direct statement, you can give this direct statement to all the people in the team only when you know Java, right? Okay, that is a different case again. So if you, there are few scenarios like where you will have multiple incoming requests that will try to retrieve data from the cache and they'll try to render the page. Okay, so most of the times what happens is the cache, what it will try to retrieve the data from the disk directly. So that is why the reason you will not see this contention issues. But when you are already using simulate new browser on every iteration, right? Simulate new user or new browser. What
Let
is that
new
option?
New
new.
user.
Simulate new user on every iteration.
Yes.
So most of the times when you try to load test, right, majority of the customers wants us to load test without cache. Contention things will not happen when contention will not happen when the data has been, when the user is trying to retrieve the data directly from the cache, the page is rendering because the data is being retrieved from the cache and it is getting the data directly from the disk. So most of the times that is why the reason you will not see contention issues. Okay, but the most common symptoms for resource contention you have are the throughput goes down, the response time, the responsiveness of the application will fall drastically. You don't even like it will go from 2.2 seconds to 13 seconds, 30.7 seconds, 81.2 seconds. Okay, the CPU utilization will go down. If you see the CPU utilization constant about 33% or 37%, now you see the 11% of the utilization. Okay, so what will happen is all the application resources, especially the DB connection pools, uh, they will be freed and they will be available all the time. If there is a lot of contention, you will not have much load on the DB. Okay, and if you have too much, if you see high number of blocked, high number of waiting threads waiting for monitor, if you see, keep this in mind. Okay, you have to remember this point. If you see more number of blocked, more number of waiting threads in these two states with a description called waiting for monitor entry state, it means that there is too much of contention in the application. There is too much of resource contention. Every one or more threads are fighting for the same resource. Each thread is not releasing the lock. Each thread is not releasing the monitor. So all these things, different things. Okay. So the overall conclusion is thread dump will give you, will solve some 40 to 45% of the problems. Okay, so thread dump, it reveals all the state, all the application behavior. It will provide you all the valuable insight of all the different states of the application, which will help us to quickly identify all the different issues. Okay, and you have multiple tools to identify multiple issues, and it completely depends upon what requirements you have. Okay, so this is all about thread dump. We have spent at least 3 to 4 classes on thread dump, right? Because uh, this is one of the important concept in performance engineering, also the heap dump. So I would ask you to uh, install all this. I would recommend you to install the profiling tools, learn Java, and read more articles on thread dump analysis and heap dump analysis. Okay, so get some good hands-on experience. And if you have any questions, I'll send you the sample heap and thread dump. If you have any questions, you can always come back to me or call me. It's always good you call me, okay? Because I don't respond on WhatsApp messages. I have so many messages that are coming from different groups, office groups and all. So I don't respond. So you can call me. Even if you drop me a message on WhatsApp, I can get back to you after 8 o'clock in the evening. I'll respond to your messages only after 8. Okay?
Yeah,
All right.
RK, one question I would have missed it, I guess. When to take a heap dump? Sorry, thread dumps. When
Thread dump,
you,
thread dump you can take during your load test. You see, if you want to see, you get some abnormal behavior, right? I mean, most of the times it is not, it is only about testing and publishing the report. But when when your customer is asking you to identify the root cause, and I need a detailed recommendations and suggestions about what's exactly happening, so you need to take heap and thread dump analysis. You do that in every test. That is now a common practice. It is not that you have to take heap and thread dump only in one scenario. To understand all the memory level statistics and all the actual behavior of the application, you need thread dump and heap dump. This again, it talks only about the middleware software, only the WebLogic and WebSphere, JPOS, the type of application server. And you also take what you take, AWR report, ADDM, Automatic Database Diagnostic Monitor, and ASH report, which is an active session history from the database. To identify all the issues from the database, you take all these reports. And to monitor all the different metrics, you need to have a good APM in place, like Dynatrace or AppDynamics or CA APM would help. So you can take thread dump anytime. Okay, heap dump also. For example, if you have an test for 2 hours and you have seen some abnormal spikes in some metrics from 1 hour 40 minutes to 1 hour 58 minutes, you take thread dumps for that particular period wherever
Can
you
we
see
take
some issue.
dumps? Can we take dumps from AppDynamics directly?
Not sure. No, I'm not sure on that, but CA APM you can take.
Okay.
Dynatrace also, I think we can take AppDynamics, and I don't know. I mean, I'm not sure. But taking a thread dump is again, it is good if you can just integrate JProfiler with your JVMs, because even your customers don't know which tool is the best. I would recommend you to use JProfiler. JProfiler is simple, integration is simple. You can take thread dumps. Very, very simple.
Okay, like when we say this web application, when there are multiple app servers and multiple JVMs inside that, so would we be able to connect from JProfiler to all of them?
You can add all of them. You can add multiple JVMs.
Okay, sure. Thank you.
So this is like a boring concept. This is a very, very boring concept, but I mean you just need to concentrate for 2 to 3%, so you'll understand the things. If you have any questions, you can come back to me anytime. Okay, so even if you see some issues from your projects also, you can ask me. I can help you on that. So that is all for today. We will talk about uh, .NET, right? Okay, we have a .NET. Okay, we have a .NET. We'll start with .NET, and then database. Okay, so we'll start with .NET tomorrow. All right. Thanks all of you for joining. Thanks for your time. We'll meet tomorrow again. All right.
Thanks. Good day.
Thank
Bye.
you so much. Bye. You too.